Welcome to our video on chemical reactions, balancing equations. In this video, we will be discussing the importance of balancing chemical equations and how to do it. Chemical reactions are the basis of life and the world around us. From the food we eat to the air we breathe, everything is made up of chemicals that react with each other to create new substances. However, not all chemical reactions are equal. Some reactions are more powerful than others, and some can even be dangerous if not properly balanced. Balancing chemical equations is a crucial step in understanding and predicting chemical reactions. In this video, we will be discussing the basics of chemical reactions, how to write chemical equations, and how to balance them. We will also be providing examples of chemical reactions and how to balance them. So, let's get started. Before we dive into balancing chemical equations, let's first understand what chemical reactions are. A chemical reaction is a process that leads to the transformation of one set of chemical substances to another. In other words, it is a process where the reactants, the substances that react, are transformed into products, the substances that are formed. Chemical reactions can be represented by chemical equations. A chemical equation is a symbolic representation of a chemical reaction in the form of symbols and formulas. The reactants are written on the left side of the equation, and the products are written on the right side of the equation. For example, the chemical equation for the reaction between hydrogen gas and oxygen gas to form water is 2H2O plus salt water 2H2O. In this equation, the reactants are hydrogen gas H2O and oxygen gas O2, and the product is water H2O. It is important to note that chemical equations must be balanced. This means that the number of atoms of each element in the reactants must be equal to the number of atoms of each element in the product. Balancing chemical equations is important because it ensures that the law of conservation of mass is obeyed. This law states that the total mass of the reactants must be equal to the total mass of the products. In the next segment, we will discuss how to write chemical equations. Now that we understand what chemical reactions are, let's discuss how to write chemical equations. Writing a chemical equation involves identifying the reactants and products and representing them using chemical symbols and formulas. For example, let's consider the reaction between sodium NaCl and chlorine Cl to form sodium chloride NaCl. The first step is to identify the reactants and products. Sodium Na and chlorine Cl. Sodium chloride NaCl. Next, we represent the reactants and products using chemical symbols and formulas. Na plus Cl2O. NaCl. Finally, we write the chemical equation by placing an arrow between the reactants and products. Na plus Cl2O NaCl. It is important to note that the number of atoms of each element in the reactants must be equal to the number of atoms of each element in the products. In this example, there is one sodium atom and two chlorine atoms in the reactants, and one sodium atom and one chlorine atom in the product. Therefore, the equation is not balanced. In the next segment, we will discuss how to balance chemical equations. Balancing chemical equations is the process of ensuring that the number of atoms of each element in the reactants is equal to the number of atoms of each element in the products. This is important because it ensures that the law of conservation of mass is obeyed. To balance a chemical equation, we can use the following steps. Step 1. Write the unbalanced equation. For example, let's consider the reaction between methane CH4 and oxygen O2 to form carbon dioxide CO2 and water H2O. CH4 plus O2 CO2 plus H2O. Step 2. Count the number of atoms of each element in the reactants and product. 1 carbon atom, 4 hydrogen atoms, 2 oxygen atoms. 1 carbon atom, 2 hydrogen atoms, 3 oxygen atoms. Step 3. Balance the equation by adding coefficients to the reactants and products. In this example, we can balance the equation by adding a coefficient of 2 in front of the oxygen molecule in the reactants. CH4 plus 2O CO2 plus H2O. Now, the number of oxygen atoms is balanced, but the number of hydrogen atoms is not. We can balance the equation by adding a coefficient of 2 in front of the water molecule in the products. CH4 plus 2O CO2 plus 2H2O. Now the equation is balanced, and the number of atoms of each element is equal on both sides of the equation. In the final segment, we will provide examples of chemical reactions and how to balance them. Let's now look at some examples of chemical reactions and how to balance them. Example 1. Reaction between iron V and oxygen O2 to form iron oxide FeO3. He plus O2 FeO3. Step 1. Write the unbalanced equation. Step 2. Count the number of atoms of each element in the reactants and products. 1 iron atom, 2 oxygen atoms. 2 iron atoms, 3 oxygen atoms. Step 3. Balance the equation by adding coefficients to the reactants and product. V plus 3O2 FeO3. Example 2. Reaction between potassium permanganate KMnO4 and iron V to form potassium hydroxide KOH. manganese dioxide MnO2 and iron Roman 3 hydroxide VOH3. KMnO plus VKOH plus MnO2 plus VOH3. Step 1. Write the unbalanced equation. Step 2. Count the number of atoms of each element in the reactants and products. 1 potassium atom, 1 manganese atom, 4 oxygen atoms, 1 iron atom. 1 potassium atom, 1 manganese atom, 2 oxygen atoms, 1 iron atom, 3 hydrogen atoms. Step 3. Balance the equation by adding coefficients to the reactants and products. 2 KMnO plus 3 V2KOH plus 2 MnO2 plus VOH3. In conclusion, balancing chemical equations is an important step in understanding and predicting chemical reactions. By following the steps we discussed, you can balance any chemical equation and ensure that the law of conservation of mass is obeyed. Thank you for watching our video on chemical reactions, balancing equations. We hope you found it informative and helpful.